Greetings to all. Today I will present the structural output and data types with the content of CNN. We will explore how CNN handle complex data beyond the simple number and how they are understand the spatial structure. Now let's move the defining the structural output. Unlike the traditional neural network that predict a single yes or no value, CNN produces a structured output. This means emit high dimensional tensor that represent this particle grid. This allow the network to understand the complex relationship between the pixel and an image. Now let us look at the high dimensional tensor outputs. A tensor acts as a multi-dimensional grid. Instead of seeing the image as flat list, a CNN sees it is as a grid of probability futures. This allows the model to output probability maps for entire images simultaneously rather than a part of time. Let's move to the pixel level of classification. One major uses of structured output pixel level classifications. In this process, the CNN is assigned probability to every single picture is an image. For example, seeing a map on right, it can be precisely diagnose between the water bodies, forest, and building across in the entire landscape. Let's move the advanced segmentation. In advanced segmentation, we create the precision object maps. This is the critical for technologies like self-driving car, the CNN isolated comparison, and road boundaries by assigning a class of the every pixels, allowing the car to see actually exactly where abstracts are. Now let us see the advantages of CNN structure. CNN have two main structural advantages. First, varying the extent and the can process image of any size, unlike the traditional network which need to fix the input. Second, efficient scaling. They used convolution kernel, which means the computations cost scales naturally with the data size. Now let's compare to the traditional NN and CNN. This table highlighted this superior of CNN for image task, while traditional network flattened image and ignore spatial relationships. CNN natively presence of the particle structure. CNN are used to kernel instead of the full matrix multiplications, making them much more flexible for high dimensional data. Now let us take the multi-dimensional data handling. CNN architecture are mathematically designed to handling three core dimensional: 1D for base data, 2D for image, and 3D for the dynamic data. The underlying the architecture's principle remaining the same regarding of the dimensions. Now let us see the common input data. CNNs are basically that handle 1D data for audio waveforms, 2D data for grayscale or RGB color images, and 3D like a one-day medical scanning for CT or MRI machines. In each case, the convolution happens across the related axes. Now let us move the domain of applications. The practical impact of technology is in the medical imaging, where AI is detected tumor 3D and scans, and the autonomous tech, where the real-time pixel-wise road identifications allows car to navigate it safely. The overall conclusion is the ability of CNN to handle the structure, output, and multi-dimensional data. What makes modern AI vision is possible. Thank you all.